now let's start SEG. Okay, and from here we will start a new project. So let's name our project. Okay, so that's the name of the project. Now let's select the project location. We will select the desktop and select OK. Now you will be able to select the module that you would like to go ahead with it. If you select the overall module, you will get all features for ducts, tanks, spherical tanks, all of that. And if you select the heat exchanger only, the module of heat exchanger, you will be able to create an equipment including a tube sheet, baffles, expansion joints, all of that. So here, let's select the heat exchanger and click on finish. Now SEG creating the project files on the defined location. And from here, let's select the project node. You can define the project number, the project name, plant location, and some other information here. Let's click on save. Okay, now the information will be saved. Here, as discussed, here you have some toolbars. You can make them float. You can select the suitable location for the bar. So by moving it, you can define the location of the toolbars you would like to add this toolbar at below here. So if we select the equipment, for example, you will be able to add the elements here. Let's move it on the right hand side. So you will be able to add head, shelf, cone, all of that, and you can get them from here. So let's close this tab to get enough area here on the main area. And by selecting the equipment, you will be able to define the design data. You can modify the construction code, the tube side values for the internal design pressure, temperature, and you can import that from an external Excel sheet. We discussed that on separate videos. So to save time, we can watch those videos, how to prepare an external Excel sheet to import it directly to SEG, and how you can deal with the values here, how you can edit. Editing by double clicking on the cell, you can modify directly. You can add rows. If you would like to add a new rows, you can add them like that. So it's easy to modify here. So if you select the equipment, you can make a rename for this equipment. If you right click on the equipment, you can make a rename like so to define the position of the equipment, if you open the setting tab and open the equipment setting, here from this form, you will be able to define the position of this equipment and the direction of the assembly, the delivered plate dimension, and length and width. Here you can define the service of this equipment. The serial number like that, and let's click on save. Now let's add some items. Let's add a first element, which is an body flange. So let's open the previous model. We have a body flange here. Okay, so from here, let's select this node, and from elements, let's add a flange. You will find the two different type of flanges here, flange and the designed flange. The flange button here for the standard flanges according to ASME or the European code or API. So by selecting this one, you will be able to add a standard flange. If you select a designed flange, you will be able to add another configuration of flanges, and you will be able to define each dimension inside this flange. So let's select this one and add the first flange, which is F1. And from F1, you will find many different type of flanges, like integral weld neck with a raised face. That shape, if you take a look to the image on the right hand side, you can figure that the raised face here is projected to the external. But for the same shape, but with a grooved face, you can figure that the face of this flange to the inside. For our case, we will select the loose slip-on flange. So we will select loose slip-on flange with a flat face. So we have a flat face here, and this configuration of a flange. Let's define the dimensions of this flange. It's 5.3 10 millimeters. 10 millimeters, the neck thickness and the end thickness, they are the same, and the neck length is 20 millimeters, and the flange outside diameter 742 for the flange thickness. The bolt circle diameter is 635. The bolt hole diameter is 32. The number of bolts is 20 millimeters. Here you can change the material of this item, or you can directly write it here like SEG. Something like that. You can directly write it. Okay, and the offset will be at 0. Let's click on save. Now let's add another item, which is a linear body flange. It's something like gasket, but it's from metal, and it will be welded to the next item. So let's create this item first. So from start, here SEG will start sending information to Autodesk Inventor to generate the 3D model for this item. Here now we have this item like that. Okay, that's a loose slip-on flange with a flat face. Now let's add liner body flange. So from here, let's select the vessel, and from the designed flange, let's select G1. That's the name of the node. And from here, let's select this type and define the the inside diameter, the thickness, and the width of this one. Sorry. And let's click on save. Now let's add a new item. If you take a look here, after adding this gasket, let's take a section. Let's take a half section here. Now we have this section. We have this gasket. It will be welded to the this part of elbow. Okay, by that way, so it's not a gasket. So let's add the next element, which is another body flange. Looks like the previous flange. So let's come here and define it to be like that. And let's add another flange. So from here, let's add another body flange. Let's name it as F2. And from this form, you can make it looks like F1 to avoid repeating data entry again. So directly from here, you can make it looks like F1. Okay, and click on Add. But we need to define one more thing, which is make it flipped to make the facing of this flange on the direction of the previous element. So let's select flipped. Okay, and from here, let's click on Start. Here, sorry, let's come back to 4. Here, so we have the elements like that. So if we take a half section, let's make a half section here. So you can figure that we have this part like this. Okay, so by using a flipping option, you will flip the direction of the flange to be on that direction. Okay, now let's add the next element, which is the elbow parts. We have 4 different parts for this elbow. That's the first part, second, third, and fourth part. The start and the end, they are different. They are not the same length. On the ducts feature, if let's open the ducts feature. Really? Okay, for the ducts feature, you can make the same elbow. Here, some features for the ducts. Yes, those type of ducts, you can make them if you have a reduced duct like this or a circular duct like that one. You can make it from 2 segments, 3 segments, 4 up 5 segments like that, and you can control the contact angle. If you would like to make it 45 degrees, 22.5, 90 degrees, all of that, you can control the number of rates. But this shape available on the duct feature. So to make it available here, you should select the overall module. But here we are on the heat exchanger module. So you can use the shell with the chamfered ends to define the each piece of those separately. And one more option here for this one, the start element, which is the first element here, looks like the last one. But here for the shell element, you can define each one separately and control the lenses of each one. That's a good option. Okay, so let's add another elbow part. So that's elbow part 1. Okay, and from here, let's select the suitable type. If you would like to make it from pipe, okay, chamfer at the end, chamfer at the start, chamfer from the 2 sides. Kindly take a look to the image on the right hand side. In our case, we will make it from a shell blade with a chamfer at the end like that. And let's define the inside diameter of this chamfer part. The inside diameter is 500, thickness 4 millimeters. The longitudinal building line is 45. the length of this one 240, and the gap of the weld is 1 millimeter. The cut angle is 15 degrees. The long edge angle at 0. And now let's click on save. And from here, let's click on assembly. Now we get this part here. One more option we will discuss for the offset. Here, if we come back to this flange, here that's the offset of the next flange. Let's define it as 20 millimeters and figure out how the result will be. Okay, you can figure that the offset become here. We make an offset of this flange. If you take a look to the image here, that's the offset. So from the next element to the facing of this flange. So if you take a look here, you have an offset with that value, which is 20 millimeters. If we measure the distance from here to there, it's 20 millimeters from here to there. Okay, so by controlling this offset, like that, and let's add the next element for the elbow. So from elements, let's open the shell with chamfered end. Let's add elbow number 2, elbow part number 2, and from here let's select the suitable type. In this case, it's chamfered from 2 ends. If we take a look to that one, this part is a chamfered from start and end. Okay, so we will select shell with chamfered from the 2 sides, and let's define the inside diameter, the thickness, the longitudinal welding line orientation, the length of this one, the weld gap, the cut angle from one side, and the long edge orientation. Let's click save, and let's add another item. So it's elbow part number 3. And if you take a look, this part looks like that one. The only difference parameter here, which is the longitudinal welding line orientation. They have a different longitudinal welding line orientation. So from here, to avoid repeating that again, we will make it looks like part 2. So let's select part 2 from this list, and from here let's select same as part 2, and let's click on add. And if you take a look to this element, you will find the same information. Or the only thing we will do, which is changing the longitudinal welding line orientation to 45, and click on save. Now let's add the last part, which is that one. So from here, let's select shell with chamfered end. That's part 4, and let's click on start. If you take a look, this part, the chamfer will be at the start, not the end. The first part chamfered at the end. Okay, so that's here the start, and that's the end here. But that one, the starts from here and end at there. So the chamfer at the start. From here, let's select shell with the chamfered at the start. Let's define the inside diameter, thickness, and longitudinal welding line orientation. The length of this one, the weld gap, and the cut angle should be the same cut angle, and the long edge angle at 0 degree. And now let's create the other items. Now the offset, change it. We change the offset again. Now the second part of the elbow, the third part. Okay, here if we remove this cut, here you can figure that you have the welding line orientation becomes like this. You have 2 identical items, but the longitudinal welding line orientation is different. Okay, now let's add the next element, which is this body flange. So let's take a section here, half section. We have a body flange, looks like the previous one. And here we have this linear body flange, which is welded to this part of elbow. After that, we have the tube sheet. So let's proceed by creating the next body flange. So from here, let's select design the flange. Here we have flange number 3, and it looks like flange number 1. They are with the same dimension. So to avoid repeating that again, we can select it like that and click on it. Okay. Let's select flange number 3, keep all information as it is, and let's add another linear part, which is G2, and it looks like E1, and let's click on add. Now if we click on assembly, okay, if we take a half section, sorry, let's take a half section here. Here we have this body flange like that, and that's the elbow. Now it's the turn to make the tube sheet. So from here, let's select the equipment, and from elements, let's select tube sheet. Okay. And from the tube sheet, let's select the suitable type for the tube sheet. Here we have a tube sheet gasketed from the two sides, from the shell and the channel side. No extended as it's not extended as a flange. That's the first type. Another type, gasketed from two sides, but it's extended as a flange, so you can bolt it with the channel side and shell side. Another type, which is a tube sheet gasketed from one side, and from the other side it will be welded to it. Like in our case here, we have this tube sheet. It's gasketed from the first side, and from the second side it's welded to the shell. So let's select this type and define the dimensions like that. So the outside diameter is 700 millimeters, the inside diameter 497. The inside diameter from the right side will differ like that. The left face thickness, right face thickness, the body flange thickness is 42. The left raised face diameter. We have a single raised face diameter, so we will not double here. If you take a look to this image, let's make a print screen and open like this. If we take a look here, we have a double raised face on this time, but in our case we need only a single raised face, not a double raised faces here. So how we can do that? So for the value of the left raised face diameter, we can make it larger than the left inside diameter. Okay, so we can increase it by that value and make the thickness here with a 0 value. Okay, so let's make the left raised face diameter larger than the right inside diameter and make the thickness of this one to be at 0. Here, let's define the bolt circle diameter. It should be the same bolt circle diameter for a flange. The bolt hole diameter is 32. Number of bolts is 20 bolts. Here, the next element clearance. If we take a look here, if you would like to make a clearance between the shell and the this tube sheet, you can define the clearance between elements from here. So the clearance between the shell and the tube sheet will be 2 millimeters. Here, from this option, you can control the orientation of the hauling. So let's come back here and take half section. Let's make a section here. Okay, let's make it okay. I think it's okay here. If we take a look from the top view, as we discussed on the orientation, we discussed that if you get the top view like that with a flipped option, you can get the correct orientation for elements like that. So here for this one, you can figure that the orientation of the holes, you can rotate it to suit your requirements. So the inlet nozzle here at this degree, so you can rotate the holes by using that option here. So you can control the holing orientation from that one. And that was one of your questions which submitted to our technical team, how we can control the orientation of the holing. So if you would like to make it in a vertical, so those two holes will start at the top here, you will make the orientation at 0. But if you would like to rotate it, rotate all the holing pattern, you can control the holing orientation from this button. Here in this model, we haven't passed partitions, so let's save those information for the tube sheet. Okay, and from here, from the tube sheet bundle, we can start generating the tube bundle arrangement. So from here, let's click on edit and start modifying the pattern. And here that's the thickness of the clearance, and the tube outside diameter will be that, and the tube clearance, each diameter, each size. And from the tube passes, we haven't any passes. And from holes, so let's define the tie rod diameter and the tie rod hole. The same for the ceiling rod, but we haven't a ceiling rod, so let's select those. And from the tie rod position, we can define the depth of this tie rod. It's 30 millimeters. Select the size of the thread and the designation of the thread. Now let's draw this feature. You can get this pattern, but actually we need to make it a triangle with 30 degrees and make the start hole starts at the center. So you will select this point, and when you click on start, you will get this pattern. So if you would like to increase the limit here, so we can change the clearance a little bit and click on row, so we get 2 holes right here, okay, which is the same configuration. The number of holes, we can get it from the bus partition. So totally we have 232 tubes inside this form. Okay, so let's discuss some other options here inside this form, like adding a bus partition. For example, if you would like to add a bus partition like this, if you click on row, you will get this arrangement here. And if you come back to the bus partitions, you will get the arrangement of tubes per each room. You have here 7 rooms. Each room include a number of tubes. Here for the first one, you have 23, but on the middle you have 45. So if you would like to move the bus partitions little bit, for example, if you would like to move this bus partition to left, so you can move it to left or to right. So you can control the number of the bus partitions like that. So from here you can control that one to left or right. like that. Or if you would like to make them symmetric, for example, if we open the tube buses by selecting those options, which is vertical and horizontal symmetrical option, if you make a draw again, but in that time, when we come back to the pass line options, when you move one pass, you will find the symmetric one will be moved like the first one here. So they will be the same. If we move that one, let's move that one up like that, the symmetrical one will be moved with that one. Okay, so that option will give you the ability to make the moving of path partitions are the same. So if we remove them again and make a draw for holes, we come back again to path lanes. If you move this path partition, okay, sorry, let's draw again. We moved it in. If we, you can figure that this one kept as it is, but that one is moved. Okay, and the same here. If you move this one, so you can control that one and keep the previous one like that. So this option gives you the ability to control the location of path partitions as they are. One more option for the holes here. If you select the vertical and symmetrical holes, if you make something like that, if you convert one of those holes, for example, to a tie rod like this, you can figure that all holes here, or all the symmetrical holes will be converted like that. If you convert that one to a tie rod, it will be like that. But if we remove that option and make draw again, if you select this one and convert it to a tie rod, so it will be only converted to tie rod, but the symmetrical holes will not be converted. Okay, so this option will give us the ability to make that. Let's come back to the tube sheet and make everything come back as it is, and let's draw. Now here we will convert this one. Sorry, let's start the SEG again. Here we have this project. Okay, here we get an issue, which is we have already this folder is created, which is tube sheet bundle. Sorry, that's the project which is demo of today, which is that one. We have this folder is created, which is include a JSON file, which includes the information of the tube sheet. Okay, so in case of creating a part like a folder like this, and you would like to modify, it's better to delete this folder, okay, and generate the tube pattern arrangement again. So from here, from the tube sheet, let's make an edit. Define the inside diameter, the thickness, the clearance. And for the tube passes, let's keep them as they are. Okay. From the tube layout, tie rod here. Okay. Okay, and select the tube layout pattern, and let's click on draw. Now let's convert this one to a tie rod. Okay, so you can control now the tie rod separately. But if you would like to make them symmetrical, just redraw again, and if you select tie rod like that, the 4 identical holes will be selected. Okay, now if you would like to add a tie rod by hand, so from import new, you can import a tie rod by that way, and you can define the location of this one. So let's make it on -45, and for the vertical position, let's make it like that. So we have a tie rod here, and the same for that one. Let's add a new tie rod, make it on 35, and like that, and click on save. Now we have those tie rods on the on this tube pattern arrangement. And now let's export the information. By clicking on this button, you will save the information of this one. Let's click on close. Now, if you would like to make a modification on this tube pattern arrangement, when you click on tube sheet bundle again, you will let's refresh that one first. Here you will start the arrangement again. Here inside the tube bundle, we have this file which includes the tube arrangement. Yes.
Sir, I am Gurpreet from SEG. Sir, I have few questions about tube sheet profile.
If you would like to modify the tube sheet profile, you will need, because it's not editable now, after creating it for one time, it's not editable. Our development team works on that to give the ability to make it like HTRI on the oldest versions. It was not editable. It's for one time. But right now they make an option to make it editable, so you can change the arrangement after creating it after the first time. Our development team works on that point to make this for editable after creating it for one time. But right now, to modify that, you will need to delete this folder, which is tube sheet bundle.
Sir,
you will need.
So can we put questions during this session?
Can we put what?
Some questions. We had some doubts about this tube sheet details. Actually, we are having some requirements regarding clad tube sheet or overlaid tube sheet.
Okay.
Whether we can draw.
Okay. Already we have some, as discussed, and I think we send you those videos here on this demonstration. If you open this video, for example, here we in this video we add a clad to here. If you come back here, for example, we discuss on this videos how to add a clad to the flanges and the body flanges. So if you would like to save time, yani, already a lot of those things is already answered. So it's better to watch it instead of spending the time on this session on repeated things. So it's up to you. If you would like to make it again, we can do it again. It's up to you.
So no, it's up to you. If you want to continue, we have no problem. But there are some doubts we are having.
You can ask here on this video. We discuss how we can make a clad on the shell, clad on the tube sheet, clad on. Okay, so if you would like to discuss that again, no problem.
No. Okay, sir. Yeah, we just want to know that we can do this on this tube sheet. There is a
okay.
We can draw it. There is no problem. Yes.
One more point I would like to discuss. You can do anything you would like to do. If SEG cannot do it, you can do it over Autodesk Inventor.
Okay.
It's not an issue. So, for example, if you have an item not included to SEG, if you would like to make a detail like, let's say, here for the tube sheet, for example, you have this hole for pressure test, for example, and you would like to make it. By the way, it's included in SEG, and we will discuss that during the session. But if you would like to make something like that, not included in SEG, how you can do it? You have a powerful CAD software, which is Autodesk Inventor. So we are dealing with this CAD software to give you the ability to do anything you would like to add to your model.
Okay.
You are not constrained with SEG. SEG will save, let's say, 95% from your model. What if you have 5% and SEG not includes those items. You can create it. You can add it to your model. So no constraints here. You can do anything you would like to add. Okay, that's the.
Okay, sir. Thank you.
For here, for the tube sheet, let's add some items like tube. Let's add a tube. For this tube, we have a user-defined length for this tube, so we can define the length of this tube to be 4 meters, and here the thickness of this tube, the offset, and let's click on save. Okay, and let's add baffles. From here, let's add a baffle 1. And from here, let's select a segmental baffle. You will find a different type of baffles. And if you would like to import or add a new type of baffles, like in your questions, the helical baffles, it's not included yet from SEG. But if you would like to add it, kindly raise a request for that. And if you would like to add any other spec, like some details for attachments, pipe supports, special saddle, something like that related to your factory, kindly contact us and our development team will include it in SEG library, so it will be available for you on the next releases. We will need an information for this element, like if you have a standard spec include standard dimensions, so you can select a size directly from this list or something like that. Just give us the information and the available sketches for this item, and our development team will proceed with that too. Let's select segmental baffle, define the inside diameter of this shell, define the cut length, the spacing between baffles, the thickness of the baffle is 8 millimeters, the clearance 2 millimeters, the location for the first baffle is 300, and the orientation will be on 45 degree. Here we will add, we will remove the vent hole, and we have 12 baffles. Let's add another baffle. It looks like baffle 1, but with a different orientation. So let's select the same as. Okay, and from here you can figure that the same options, but from here we will change the orientation of this one. Okay, and they are 11 baffles only, and let's click on save. Now let's start the Okay, one more thing here, if you can figure the location of the second baffle, we changed the orientation only, but the location we didn't change it. So from here, from the location, edit the location and start reassembly again to modify the second baffle location. Now we have the second baffle. Let's add the other items like shell, the second tube sheet, and after that proceed with tube sheet hauling and tube pattern. So from here, let's select panel 1, and let's add the next element, which is, let's remove this section. We have a shell course here after the tube sheet. So from here, let's select the vessel, and from elements, let's add can. So let's add can. The inside diameter. Let's select the type. Here you can add a shell as a pipe or a pipe with a weld line. So you have a standard sizes of the pipe, but it includes a weld line. Or you can add a shell without any welding lines. You can use it if you are preparing an offer and you would like to get weights without any details. Like if you have an LBG with, let's say, 50 millimeters length with the same thickness, so no need to make it in detail as a shell courses or something like that. You will need to calculate the weight, so you can use that option for the offering period. Okay, here in our case, let's select shell. Define the inside diameter of the shell. Define the thickness, longitudinal building line orientation, length, the gap length, and let's click on save. Now, if we click on start, we will create the shell course. Okay, after the shell course, here we have an expansion joint and another shell course. So if we come back here, let's add an expansion joint. So from here, let's select expansion joint. You can figure that you have different types of expansion joint. By the way, we make some modifications. It will on those types of expansion joints. It will be available on the next releases. One of them, we include this type of expansion joint, which with that configuration like that, as per one of our customers' request. Okay. So the available types here, as per the drawing, you can check the detailed drawing for each part. In our case, we will select the expansion joint type B, which include a straight edge here on the middle, and two different straight edges at the start and end, and a width, side width like that. And you can control the number of expansion joints from here, the number of expansion. So let's define the expansion joint dimension, the inside diameter, the thickness, the width, the expansion joint, the height, inside height, which is dimension H as per the drawing. The number of expansion joints, we have two parts, and the inside radius, here we have 30 millimeters, and the edge, which is dimension E, is 50 millimeters, and the right extension and left extension is 25. Now let's accept this, and from here let's start the assembly. Now we have this expansion joint, and let's add the next element, which is the shell. So let's select the vessel, and from here let's add can 2, and let's make it look like can 1, and let's click on add. Now we will change the length and the longitudinal welding line orientation, if you would like to change the longitudinal welding line orientation. And we can check that after adding nozzles. If we found any clash or interference, we can change that. Here you can change the orientation, and from here let's change the length of this shell like that. And let's add the next element, which is tube sheet number 2. So from here let's select tube sheet 2, and let's make it looks like tube sheet 1. Okay, they are the same. And from here, if we make it same as the first one, so the profile of the tube sheet, if we make a cut here, half cut, the profile will be the same, but we need to make it flipped. So we will get the clearance here on that side, and that one will be connected to the next gasket. So from here, we need to make it flipped. So let's select on flip and click on save. Now when we click on start assembly, now we have this tube sheet, and we get the same gap here between the tube sheet and shell, because we make a flip option here. Now let's create a tube hauling for this element. So let's come back to the tube sheet here, and from the tube sheet hauling, let's open this form. By the way, this form you can use it to import an external HTRI CSV file. From HTRI, you can export a file, a CSV file, which includes the location of hauling in X and Y direction, and the whole diameter, tie rod diameter, all of that. So from here, here, you can import this file. But in our case, we generate this file automatically from SEG. We generate the arrangement of tubes in this file by that way. So the location of tubes in is like that. And just only we will click on start hauling to proceed with the hauling pattern on this tube sheet. Okay, so let's check that. Here, SEG will check the required items and start creating the, as you can figure, the tube hauling takes 45 degrees orientation that we defined on the tube sheet hauling orientation. So it's important, if you would like to change the orientation, you will need to define it from the form of the tube sheet. Here we prepared the hauling on the first tube sheet, the second tube sheet. Now the tube pattern arrangement automatically created. After that, the baffle hauling. The second baffle hauling. As you can figure, we didn't add tie rods to this assembly. Why? Because we have two different lengths for the tie rod, and we will make that during the training course, inshallah. We will make that by using the SEG helper library.
Sir?
Yes.
This is Vibhor Singla from SEG. I have a question regarding the importing of the files from PVLead and HTRI. So we actually tried using the PVLead file import into this program, but that was
for pressure vessels only. Well, sorry, for pressure vessels only from PVLead. The access database file for pressure vessels only. Okay.
But sir, it didn't work for pressure vessels also. We actually tried for pressure vessels also.
Again, please. I don't get your point.
Sorry, sir.
I didn't get your point. Again, your question again, please.
Actually, we imported both heat exchangers as well as pressure vessels as an input from PVLead to this particular software. So both pressure vessels and heat exchanger didn't work out to be as per the expected for this SEG report.
Okay.
So it didn't work for pressure vessels also. That's what I'm talking about. So how do we get to that?
Okay. You will find many tutorial videos in our channel discuss the integration with the PVLead and how you can import the access database file in a correct way. The point is, when you export the access database file from PVLead, you should export it in a certain format. Okay. So the dimensions should be in millimeter, and the naming of elements should be unique. That's the first point. Not including any unexpected characters. For example, here if we let's open a new folder. That's after finishing this. Let's open a new folder here on the desktop. Okay, and let's try to create a new file. Let's say a Word file. Okay, that's only to show you how things goes on. Now let's try to add unexpected character like question mark. Try to add a question mark. It will not be available. So sometimes the naming of items in BVEdit, including unexpected characters. So Windows cannot create it for the file. So for example, if you make a head with a name, start with, let's say, a backslash or question mark, or include this character. SEG will accept it, but when try to create it, SEG will not be able to create a part with that name. So we're facing an error. Okay, but it's not a SEG issue, it's a Windows issue. You cannot create an element with unexpected characters. Okay, so on our training videos, we discuss a lot of those things. We access database file from BVEdit, and you.
Sir, could you please give me the reference of that particular video? We will be very thankful for that.
Okay, I will share that with Ratchet, and Ratchet will inform you about those videos. Okay, I will prepare a list for this video so you can watch them and to know how to export the Access database file in a correct way and how you can modify on the Access database file. Sometimes you will need, if you export the Access database file with some wrong information, how you can modify on it. So that will be indicated on the training videos, and you will.
Please include the HTRI file part also in that particular video, no?
Okay, inshallah.
Okay, thank you very much, sir.
Sir,
Yes.
I have another question regarding tube sheet.
Yes.
Sir, can you provide nozzles on tube sheet because it is not provided in SEG?
Can we provide what?
Nozzles on tube sheet, sir.
Okay. During the session, inshallah, we will discuss how to use the Unreal elements as we mentioned here.
And sir, I have another question. When we delete, sir, holes in a tube sheet,
again, please?
By using the delete feature that you provided in SEG, sometimes, sir, the holes are not removed in second tube sheet.
Okay, you can delete it. Okay.
It's shown an error.
Okay. So if it's not deleted, as I informed you, you are dealing with a CAD software, so you can do anything you would like to do. So here for the second tube sheet, for example, you have the feature of this tube holing. Okay, so easily you can move the tree end like this, so you will delete this feature, or you can right click and delete it. It's easy to do that. Okay, but SEG will help you to make all of that easily, make the arrangement of tubes, make the drawing easily. So if you would like to make something not, you get an error or facing some error, it's easily to solve it. Don't worry, inshallah. Okay, here we have, yes.
Sir, there is no zoom in, zoom out option is provided in tube sheet profile. When we draw the loads of like 2000 holes, then it is not visible for me to select the particular tie rod holes and
if you have HTRI, if you have HTRI and you already designed it on HTRI, you can import it from HTRI file directly. So you will not to make any modification. It's already created on HTRI. So you will import it directly without making any modification.
When we want to draw it,
so if you already have HTRI and you make the tube pattern arrangement for one time, why you repeat it again on SEG? That's the question. If you already make it, so why you repeat it again on SEG? Just include the exported CSV file.
Another question is that how can we use the baffle impingement option, tube raw option, sealing strip option in tube sheet bundle design that you have given in the SEG software?
Okay, during the session, inshallah, after creating the nozzles, we can add or discuss the available different types of impingement baffles, okay, and how we can add them. And if you would like to add, let's say, impingement baffles as rod, how you can do that, how you can add spaces.
I have many of question about tube sheet design. Can we ask after when you say after training, after this session is over, can we ask?
Inshallah, sure, inshallah.
Okay, sir.
Okay. That's the second tube sheet. Let's add another linear item like a gasket. So from here, let's select design gasket and design flange, and let's add this part, which is G3. Okay, it looks like G1. Okay, the same dimensions. After that, if we come back here, after adding this, we have the tube sheet, and let's take a half second here. Okay, we have this one, another body flange, another shell course. So after adding this basket, let's add another body flange. So from here, let's add the design flange. It's F4, and it looks like F2. Okay, if you come back here, this flange looks like that one, the same dimensions of that one. So we will make it with the same dimension. So directly you can select same as F2 from here to avoid repeating dimensions again. And after that, let's add another can, this can 3. And from here, let's define the can dimensions. Select this one, the inside diameter. The thickness is 4 millimeters, the longitudinal welding line orientation, and the length is 200 millimeters, and the gap width is 1 millimeter. Now let's add a centric cone from plate. So let's add cone. Here, let's select a centric cone, and let's define the inside diameter, the thickness 4 millimeters, the longitudinal welding line orientation, and the length, gap thickness, the gap width, and the end inside diameter. Let's click on save. Let's add another can 4. It's as a shell plate, the inside diameter, longitudinal welding line orientation, length, and the gap width. Okay, and let's start the assembly. Okay, we have those items for the cone, the shell plate. Now let's add flanges, this one. So from here, let's select the equipment, and from here, let's select body flange, and let's add F5, flange number 5. And from this list, let's select loose slip on but with raised face. Here we select on the previous flanges, we select a loose slip on with flat face. But this time, let's select loose slip on with raised face. Let's define the flange dimensions. The flange face out.
Sir.
Yes, go ahead.
Sir, how can we use lap joint type flange in SEG and tongue and groove type flange?
It's not included.
Okay, sir.
Okay, sir.
Okay, so let's click on save. Now let's add a gasket, a simple gasket. So from here, let's add gasket, which is G5. It's a user-defined gasket. The inside diameter, the thickness, and width. Save another body flange at the end. So it's and from here, let's select. It looks like F5, but it will be flipped. So from here, let's select this one, and let's select flipped option and start creating those flanges. As mentioned, if you would like to include some items, kindly share your requirements with us, like the configuration of the flanges that you would like to include. If it's sorry, if it's have a standard dimensions, kindly share with us a list of dimensions of this type. So that will give our development team can proceed with this. For example, I would like to show you something here for on the nozzles. For the you asked me for two different types, which is lap joint and what is the second type?
Tongue and groove, sir. Sir, tongue and groove.
Tunnel group. Tunnel groove.
Face type flange.
Okay, would you mind to share those types with us after this session? Would you mind to share that with?
Okay, sir.
Okay, thank you so much. Okay, here let's add nozzles to this one. So let's remove this section. Here, let's add an inlet and outlet nozzle for this model. After that, we will add the support, earthing lug, and the available items in SEG library. After that, we will proceed with adding the external items, like adding tie rod with different lengths, add spacers over the tie rod, add impingement baffles, and let's discuss the available types, and if we have another type not included in SEG, how we can do it, all of that. Okay, here let's come back to SEG, and from here let's select the main item. So here, if we remove this half section again, we need to add a nozzle to this can. Okay, so this can, it's can 1. Okay, so let's select the can here from the tree. So we should select the correct main item. So from here, let's select can 1, and from elements, let's select the nozzle, and let's define the nozzle name, which is this one. Okay, and from here, let's select the suitable type 4 nozzle. Here you will find a nozzle from pipe, nozzle from plate, tangent nozzle, long weld neck nozzle, self-reinforcement nozzle. Many types of nozzles here. You will find it, more than 25 types of nozzles. In our case, we have a nozzle from pipe with 2 inches with a reinforced pad. So we have a reinforced pad here with 50 millimeters, and the scalable of this nozzle is 160. The location of this nozzle on 190 millimeters. The orientation is 225, and the name of this nozzle is gas inlet or water inlet. Okay, and let's click on save. Now the projection is a default value. We need to modify the projection of this nozzle. So from here, from the external connection, you will find an external. If we take a print screen like this and like that, you can figure that you have an external connection on this nozzle. So this external connection, you can add elements to this end of the nozzle. So from here, let's select the external connection of this nozzle, and from flanges, let's add a flange for this nozzle. So it's one flange. And from here, you will find the list of flanges. Those are standard flanges. One of them here is the lab joint flange, this one, but it's not available in heat exchanger. Okay, you can use it on nozzles, this type. And as mentioned here on that one, let's take, yes, okay, part of section. Take this one, continue. One. Sorry. As we did here, we use this feature, which is linear flange as a metal gasket here, and it will be welded with the shell element or the plate element like that. So you can use this type if you would like to make something looks like the lab joint. But for nozzles, you can use this type, which is lab joint flange with that configuration. In this case, let's select weld neck raised face flange according to ASME 16.5. Select the size, the same size nozzle, and from here select the scalable and click on save. Now if we come back to the nozzle and open the calculator form, here from the calculator form you can calculate the projection of this nozzle from center line to the facing of the flange. Okay, as per this image here, if we see here, the projection will be calculated from the center of the vessel up to the facing of this flange. So you will define this value from the vessel center line to the facing, and automatically the projection will be calculated here and will be reflected on that value. So this value will be calculated automatically based on the calculation inside this form. So let's come back here and check the calculation. If we make the projection is 500 millimeters from the center line to the facing, so the projection here will be 182. Okay, 182. And if you click save, automatically it will be reflected here. Okay, so if we click on start simply, the nozzle will be created right here. So if we take a half section like that, okay, and take a look to the tube arrangement, you can figure that the cut is below the nozzle, so the flow will come like that. So if we take a print screen here, so the flow will take that direction. Okay, let's increase the thickness of this line. So the flow will take that direction, and here we have the cut on this area. So that's the cut line here that we have. That's the baffle cut. So the flow comes here and go from that side. Okay. Come back here and add the second nozzle. Before going to the second nozzle, let's define the weld configuration of this element. Here, SEG include a standard of welding details, a library of welding details. So automatically, it's detected that it's a nozzle with a rebad. Okay, and SEG will give you some options to control the welding preparation, like if you have a single V or double V. So if you have a double V, the weld style will be changed like that. So if you have a single V or double V, it will be like that. And if you would like to make it with no clad, like in this case, or if you would like to make a clad on the parent element, so you will have a weld overlay here and a clad inside the main element, if it's a head or shell or cone. And if you would like to make a clad on both main and the child element on the shell and nozzle, you will select this option. In our case, it's no clad, and let's define the fillet weld for the rebad and the element dimension A, which is if we take here, if we, you can figure that dimension A is the fillet weld between the rebad and the nozzle, and dimension B is the fillet weld between the rebad and main element, if it's head, shell, or cone. So you can define the fillet weld like that here. So if you click on save and come back to tables, and if you open the nozzle table, we open the nozzle table here, you can figure that for the weld detail, automatically the weld style is changed and the dimension of the weld reflected here to this table. Okay, let's add another nozzle. From here, let's add another nozzle to CAN 4. To CAN 2. If we come back to the 3D model, let's remove the section. We need to add another nozzle to this CAN, which is CAN 2. Okay, so let's select CAN 2 from the tree, and from elements, let's add second nozzle, which is S2. And by the way, if you select same as here, this option we don't recommend using it on nozzles. Why? Let's try to show you why. Here, let's add it. As you can figure, the nozzle, when you add it, it's added to the CAN 1, not CAN 2. Okay, because this selection gives you the ability to add the same nozzle on the same main part. Okay, so after adding it, you can figure that it's added to S1, to CAN 1. Okay, the second issue here, this nozzle will not include an external connection. So if you would like to add an external attachment to this nozzle, you will not be able to add it. So the right way to add a nozzle, as a previous nozzle, by adding it by that way. So the first step, selecting the main element. After that, selecting a nozzle from the elements and define the nozzle name S2. Okay. After adding it, now you have this nozzle, which you named S2, and now it's including an external connection. By selecting S2, you will find here on the right-hand side this drop-down list. Okay, if you select the nozzle S1 and click on save, that means nozzle S2 will looks like S1 with the same dimensions. Okay, to make a refresh for this view, you will need to go to another point. So the dimensions not changed right now. You will need to make a refresh for the interface. So how to make that? Select any node. After that, come back to S2. So you can figure that the dimensions are the same. You will need to change the orientation of this nozzle, which is 45, and change the service of this nozzle as nozzle outlet. And click on save. Now let's add a flange. So by the same way, if you add a flange to external connection like S2 flange, if you make it looks like flange 1, automatically it will become after S1 flange. Let's try this. So let's change the name. If you click on add, automatically, as mentioned, it will be located on the main element of the selected same as element. So we don't need it here. We need it here. So to how to add it and make it same as S1 flange. So from here, let's select external flange and S2 flange. After adding it, by the same way, you can select the flange, and from here make it looks like S1 flange and click on save. Automatically, you will get saved successfully. If you would like to review it, kindly go to another point and make a refresh. Here, that's it. It's a Wildenig wrist face according to ASUME B16.5. The same rating, the same size, same scribble, same material, all information. Now, if we make a run for nozzle, okay, we need to change the location of this nozzle to become after the last battle. So if we take section here, so we changed the orientation, but we didn't change the location. So the location of this nozzle, we need to come back to this nozzle and change the location. So as mentioned on this slide here, that one, the location of the attachments, it's related to the main element. So the location of this nozzle, so if we make a print screen and so the location of this nozzle here, let's change the center line of this nozzle here. It's referred to the location from the start here. Okay, so it's related to the main element. So here, let's change the location of this nozzle to that value and click on save. Now let's click on start to change the location of this nozzle. Now we have this nozzle after the last battle. Okay, now let's remove the CAD view. Now let's add a support lug. Okay, and let's add a nozzle. After that, we will add a nozzle to the expansion joint. And we will learn how to make that by using Unreal elements. First, let's add a support lug. So from here, from elements and from support group, let's select lug. And from here, let's add support lug. Okay, and let's select the first type. Let's define the dimensions. Keep the material as it is. Fixing. Let's add a wear plate. And the location of this one, meters, degree, keep it as it is, and we have to support lugs. And let's click on save. Now let's start the assembly. Here, as you can figure, the elements during creation created on behind.
Hello, sir.
Yes.
Sir, I have question about lifting lug.
Supporting.
Yeah.
Supporting lug. Sir, when how can we use two hole in supporting lug, sir?
this option is not available. But how you can do it here? For example, here we have one hole. So if we open the main element here, we have this support here, and we would like to make a modification on this base plate. Okay, so let's open this one and make the modification to suit our requirements. Here we have a hole with those information here, but actually we don't need it by that way. We need 2 or 3 holes by a different configuration. One of them is a slot hole, for example, or 2 slot holes, or 2 slot holes vertical or horizontal on that direction. Like we actually we need to add a hole on that place, and another hole here, like that. How we can modify that? Or if we would like to make a slot hole here, okay, a slot hole here, and another slot hole there, for example. Okay, that's the task now. Okay, let's come back here, and for this hole, let's suppress this feature. And now let's create our own hole. So let's select this surface, and from here, let's add 2 points and define the offset of this point, and make this one horizontal with that one. Okay, so they will get the same dimension. And here we have this hole, looks like that hole spacing. Okay, so the center of those holes come like this. Okay, now let's convert those lines to construction lines, and from here, let's select the hole feature. So from holes, automatically we will select those, and from here, if you would like to link it with SEG, you will find the parameter here, which is hole diameter. So you can link it with the hole diameter directly. So let's select hole diameter. Okay, so if you change the hole diameter from SEG, it will be reflected here. Okay, so let's try this. Now we save this one. So let's upload this as like that. And now let's make this hole with a larger diameter, or increase the hole diameter. Here we have 24 millimeters, so let's make it 15 millimeters diameter and click on save. Now if you click on start and come back to SEG, here you can figure that you increase the hole diameter of this slot. Let's open this part again. So let's open this simply and open this part again. Here you would like to make change the location. You figured out that the hole here is too close to this rib, so let's change the location. So easily you can come back to the sketch and define the location, make it 75 and click on save. Now you change the location of the holes. So if you would like to make them as slot holes, so now let's suppress this feature. So let's suppress this one and select this face and make 2 slot holes. By the way, SEG give you the ability to make a sliding hole, but one hole, one sliding hole, not 2 holes. Okay, so if you would like to make 2 slot holes, so from here, let's select this one. So, and from here, let's select holes to make them the same and let's the same. Okay, and now let's define the side diameter. 25. Make them parallel. So from here, like that, make this slope of 50 millimeters. Define the offset from here to 50, and the offset here to there has 60 millimeters. Same for this one, 60 millimeters. Okay, and now by using extrude feature, we will make a hole for this one. So cut through all. Now we have this slot hole, and if you come back to the second one, it will be the same. So you are dealing with a CAD software, a powerful CAD software, which is Autodesk, which give you the ability to make a modification or make anything you would like to do. Okay, so no constraints here. If SEG have some constraints, but with Autodesk Inventor you have any constraints, no limits. You can do anything you would like to add or modify in your model. Okay, now after modifying this support plug, let's add a nozzle to the this expansion joint. How we can do that? If we come here to the SEG tree and select the expansion joint, from Elements tab here, you will not find any attachments to. You can add it to.
Sir, I have question regarding
Yes.
sir hole. If we reset the sir manual work that we done on the sir SEG software Inventor. Hello.
I don't get your point. Or what is your
Sir,
question again?
When we reset these Inventor items, then can it remove the manual work that we done on the Inventor? Like you can use slots, 2 slots in the lifting spot. When we reset this lifting spot, can you remove it?
Okay. Here after creating this this modification here, if you would like to remove it, that's your question, or because I don't get your point correctly. If you would like to
reset that part, if we reset that part,
yes, if you make a reset for this part, you will lose your modification.
Okay.
If you if you come here from edit and make a reset inventor model, so you will delete all inventor elements. So no modifications, no manual modifications stored here. You will delete all items. So when you generate this model again from scratch, you will get the default shape.
Sir, what is the use of reset changes button that you provided in SEG?
Again, please.
Sir, what is the use of reset changes button that you have provided in SEG?
I don't understand what you would like to say.
What is the use of that reset button?
Reset changes button.
Yes. Okay. As mentioned, reset inventor model. Okay, reset inventor model will delete all inventor items in your project, parts and assemblies. So you will delete all parts and assemblies. Okay, but here for the reset inventor item, let's try it. Okay, for the reset inventor item, we make some modifications here for this item, and we figured that those modifications are not correct, and we need to get the default configuration again back. Okay, so in this case, if you select this element, which is support log, and click on reset inventor item, so you will delete the inventor items for this part only, not all the project, this item only, which is support log. So let's try this. Okay.
Okay, sir.
Okay. So let's try this. If you click on reset inventor item from here, okay, reset items succeed. Now when you click on start, let's click on start. This item will be deleted and created from scratch again. You know?
Okay.
So you will lose your modifications. Here you will get all the configuration for this. That's in case of using the inventor item. So by using a reset inventor item, you will delete the selected item on SEG 3. Okay. Okay, now let's make another option. Like you make a modification for this support, but you don't need to make a reflect for it. For example, here we change, let's say, the offset here. Let's make it like that, the offset of the hole. Okay, you can figure that you will get this part with a red color. Okay, here we have 3 different colors on the tree. the black color, blue color, and red color. The difference between them, the red color, that means the item not created on Autodesk Inventor yet, or need to update on Autodesk Inventor. Here, this item is already created. It's already created, but we need to make an update for the parameters of this item. There is some, or there are some parameters change. Okay, so here the red color means this item need to be updated on Autodesk Inventor or not created on Autodesk Inventor yet. Okay, the blue color means this item not need to be relocated or reassembled again. Let's try this. Here, if let's add, as we discussed, we need to add a nozzle here on this expansion joint. Okay, and this expansion joint, we need to add unreal element. So here we will add a connection point. Okay, this connection point, let's add it here. It's a shell type. You will say it's a shell type. Here, one more point. I would like to, let's go out from this point 1 minute to indicate one of common mistakes here. For the selecting another node, the second one. Okay, the second one here, which is selecting another node without checking the appearing form. That's one of the common mistakes. Here, I selected this one, but when I'm selecting it here, I select it, but don't care that I'm selecting the icon here. I should select the icon to get the form appear here. So when you make a selection like that without keeping care about the selecting point, you may get a wrong form. So you should select the one. Here, let's select one of those options, which is connected point for nozzle as a shell. Okay, as you can figure, if you take a look to the image on the right-hand side here, it's not a real element. You can use it at the end of nozzle to add a child to this nozzle, like coupling or something like that. So those types, you can use them to add attachments to another elements, not include childs, or to another child. Like if you have a nozzle and you would like to add a coupling to this nozzle. Okay, so the nozzle itself, it's a child, so no option to add attachment to this nozzle. So if you select a nozzle, for example, you haven't an option to add a nozzle, another nozzle to this nozzle, to connect a nozzle to this nozzle. And let's try this after making the nozzle on expansion joint. So let's come back to the expansion joint here and check the inside diameter here. So let's make it this one. We need to measure the value from the inside here to there, because we need to add a flange, add a nozzle on that place. Okay, so we need to measure or calculate the inside diameter of this one. So we have this inside diameter, we have the height. Okay, so here we have the inside diameter 488 plus twice the thickness, which is 20. So the inside diameter here is 508. Okay, so let's come back here to SEG and select the connection point, and let's select connection point for a nozzle as a shell. Define the inside diameter, which as we calculate 5.8, and the thickness is 10 millimeters. Now this connection point is after F6, but we need it before the expansion joint. We need it here. Okay, now the expansion joint, this connection point will be laid here after this flange, but actually we need it between this shell and this expansion joint. So we can move it by right click on this node, and from here by selecting a move, you can make it select move before the expansion joint. So from here, if we select the expansion joint and click on move, now you can figure that we move the connection point before the expansion joint, and the blue color appears. Okay, so as discussed, we have three different colors on the tree. The first one, which is the black one, for the generated items on Autodesk Inventor, no need to assembly or no need to update because they are already created and updated. The red one, that means this item is not created yet or created but need to make an update for the parameters. The blue one means this item need to be assembled, reassembled again. Here, if we screen, you can zoom here, you can figure that you have three different colors, and the blue one means this item need to be reassembled again. Here, after getting this connection point before the expansion joint, SEG will need to assemble this item with shell. Okay, so here we need to assemble this connection point with the shell. After that, make another connection between this shell and the expansion joint, and the same with the expansion joint and the next shell. Okay, so here SEG will make rearrange the assembly again. That is the meaning of the blue color. Okay, now let's start the assembly again. Now we update the support plug hole location. And here we have the connection point before the expansion joint. Now we need to add a nozzle to this connection. So let's select this connection point. And from here, let's add a nozzle. Okay, so let's add this T1, the temperature indicator or pressure indicator. Okay, and from here, from this connection point, let's add this nozzle as 1 inch nozzle with scalable, let's say 40. The location, to calculate the location and put it in the right way. So let's calculate the right location for this nozzle. Let's add a quick view here. For this one, we need to add the so the location will be on 120 millimeters, so 120. The orientation, let's make it on like that, or make it on 0 degree, no problem. Okay, pressure indicator, and let's click on save. Now let's add a flange to this nozzle. So from flanges, let's select P1 flange. And if you would like to add an outlet or something like that, you can add it to this external connector. So from here, let's add a flange. Let's select slip-on flange. Select the size to be 1 inch, and the offset is 4 millimeters, and click on save. Now let's calculate the projection of nozzle T1. So from the calculator, yes.
Sir, I have a question. Can we use the lap type flange instead of slip-on flange? Can we use the lap type flange instead of slip-on flange that you use in it?
Okay, no problem. Here we have this flange, so let's select lap joint flange. Select the same schedule. We select, I think, 40, and the stud end length. Let's make it like that, and click on save. And from here, let's change the sorry. Yes, I changed it this one to lab. Okay, and from here, change this one, and from here let's click on start simply. And now we have a nozzle here on this one, like that, on the expansion joint, by using the technique of connection points for unreal elements. So here let's add a coupling to this nozzle. Let's add a coupling to this nozzle. How to add a coupling for this nozzle, or weldol it for this nozzle? By the same technique. Here we have this nozzle connection and no ability to add attachment to this one. But if we select the external connection, add a connection point for this one, T1 connection point. Okay, and let's add it like that. And from here, let's select the this element, which is connection point for nozzle as a pipe. Okay, and define the pipe size, which is 1 inch, and the scalable is 40 millimeters. And let's click on save. Now we have a connection point at the end of this nozzle. So we have a point here, connection point here, like a shell. It looks like a shell. Okay, so we can add elements to it. So if you select it, you will find that you can add all of those elements. So in that case, let's add a coupling connection. So T1 C1, which is T1 coupling. And for this coupling, let's select the rating of this coupling, select the size, which is, let's make it a half coupling. So it will be like that. The location. Okay, the location, if we define the location for this one, so let's look at things here. Here we have a point at the end of this nozzle. We have a point here. Let's increase. We have a point at the end of this nozzle. So the location will be calculated from here to there. So if we add the calculation, let's say for 100 millimeter. So the location will be on that direction, but we need it on the other direction. We need the location of the coupling with a negative value. We need the coupling at this position. So the location of the coupling will be with a negative value. So let's come back here and define the location, but with value like that, and define the projection of this one, and define the surface of this coupling. And from here, let's create a coupling connected to this nozzle. Okay, as you can figure, we have a coupling here located on this nozzle, and we can make a connection on this coupling. So you can connect a threaded pipe, you can connect a T. So if you increase this a little bit, you have a connection here for this coupling at the end of the coupling. So if you would like to, let's add a threaded pipe. So from here, let's T1 pipe 1, like that. So from here, let's select threaded pipe from 2 sides. Select the size. Okay, select the scalable, and from here select the length like that, and select length here, and click on start. Now we have a threaded pipe connected to the coupling by that way, and by that way you can make add your device or something like that. If you have a device you would like to add it for pressure measuring or something like that, and this device is not included in this SEG, you can add it. By the way, you can add a manometer here, for example, to measure something. But anyway, you can build your tree. Like if you would like to add a threaded coupling, for example, but the sizes, I think it's not will include 1/4 inch, but let's check the one for the threaded equal T here. I say, okay, it's included this size. So if you click on that one, you can connect it from the branch, or you can connect. As you can figure here, you have a branch and another inlet. So if you here you have branch connection and the inlet connection. So the first inlet connected directly to the pipe of the branch, and the second inlet will be free. You can connect elements to them. Okay. So here, if you make simply, you will get a threaded T by that way here.
Sir.
To this pipe. Yes.
Sir, I have a question. Sir, how can we use lab type flange without T1 nozzle that you use in it?
No, it's
without
not
pipe or T1 nozzle, sir.
It's not possible.
Because
okay, you can make it by another way, but it will not be. Let's say it will not be a nozzle on the nozzle list. That means, okay, let's try to add this lab flange, okay, lab joint flange to this expansion joint, but without this nozzle. That's your question. Is that right?
Yes, sir.
Okay. Okay. So by using another way to add unreal element, another unreal element, which is a nozzle. Unreal nozzle. Okay. So let's select the connection point, which is the previous of the expansion joint, this connection point. And from here, let's add a nozzle. And this nozzle will be connection nozzle. Okay. So we will select a type here on this nozzle. So not a real nozzle. It's no elements inside it. Here, for this one, nozzle connection point, you can use it in case if you have something special, like you would like to make an elbow or a cone directly welded to the shell as a child instead of a nozzle. Okay, like for example here, let's take a print screen for this view to show you what I would like to say. Let's take a print screen and come back here. Sometimes you would like to make an elbow. Increase that one. You would like to make an elbow directly welded to the shell. It's not a nozzle. Okay, so how to make a parent element connected to another parent element, something like that. Here we have the same case. We have a parent element, which is the lab joint flange. We would like to make it directly welded to this one, directly to the expansion joint without a nozzle exit. We need to make a cone here. Let's make a cone directly welded to the shell. So by using this technique, you will be able to make that. So from here, let's select nozzle connection point. The estimated diameter that you will calculate, add the connection on it. The thickness will be keep it at 0. The location and the orientation 190 degree. The projection, no projection, keep it as it is, and let's click on save. Now, when you select the external connection of this element, you will be able to add a lab joint. So from here, let's add T2 okay, to this one. And from here, you can select the lab joint. Let's define the rating, define the size, scalable and the stud length, and let's click on save. Now when you click on start assembly, you will get this result. Okay, here you have this lab joint directly connected to this expansion joint. Let's take a half section. Like that. Okay, so by increasing the estimated diameter of this one. Okay, so here I think the connection point inside diameter, this value is not correct. So let's come back and make another sketch to measure the inside diameter. Here, let's make this one with the hidden lines to get the inside diameter here from here to there. So the inside diameter is 680. It's not 550. So that's the correct inside diameter. So let's come back here. And for the connection point, let's define this value to be like that one. So it's 680 and click on save. And don't forget to save all childs. That means this parameter will be reflected to the other childs. Now let's start the assembly. So here the location of this nozzle is modified. And the second one here for this connection point, let's define the because it's a connection nozzle, not a connection point. So from here, let's define the dimension. Okay, and let's update this one. So here you will get this nozzle like that, and if you would like to make it sit on or sit in, you can change the thickness, this projection, or you can change this value. So let's decrease it to that one and run the assembly to make it sit on, not sit in. Sit in, not sit on, like that one. So you, by that way, you can add attachments to another attachments, or add a parent element to another parent element as a nozzle exit. Okay, by the same way as discussed here, you can add an elbow if you would like to add elbow as a nozzle, or add a reducer as a nozzle. By the same way that we did this one, you can do that by using the same technique. Okay. Here for the T, let's discuss one more point for this T before proceeding with the next element. Here, this T, you can figure that it's connected from the inlet, the first inlet. But if you would like to connect it from the branch, when you come back to the T, here you will find an option here for the connected from branch. So when you select this option and click save, automatically you will figure that here you have two inlets. If we print screen this and zoom here, you will get inlet 1 and inlet 2, because this T now connected from the branch to the previous element, which is T by 1. If we make a run for the assembly, here this T will be reconnected to be connected from branch like this. So the first inlet and outlet will be free. Now you can connect elements to those items. Let's check that. So if you select the first inlet, for example, and select T1 pipe 2, for example, and click add. Now if you make this pipe looks like T1 pipe, which is a pipe, sorry, which is a pipe, we can minimize the length and minimize the thread length. Save. Now when you click on start, you will get a pipe to the inlet 1, connected to the inlet 1, like that. Okay, so you can make a piping here by adding threaded elbow or something like that on the attachment. That's the way of using the Unreal elements and like connection point as a parent element, or unreal element like a connection nozzle, to add attachments like that. Okay, but take in your consideration that the nozzles, if you open the nozzle list, you have this nozzle, which is connection nozzle. Okay, it's not defined as the connected nozzle here, which is that one. It will not take the property of this nozzle. Okay, so you will need to make a modification on that table after importing to your drawing regarding to this nozzle. Okay, because it's not include the information of the attached parent element, because as we discussed, that's a parent element, not a nozzle yet. Okay, but that one is a nozzle because we're using a nozzle, so the information for this one is already included, and you can modify it on the table from SEG. Okay, now let's add some external attachments to this model, like adding tightening bolts, adding tie rod for the tube bundle with different lengths, add some earthing lug, trunnion tailing lug. Okay, so from here, let's open the SEG library. Let's open Autodesk Inventor, and from here, if you click on New, you will get a folder here as SEG item template. That's the SEG helper template. You can use it to generate some pre-built items. They can help you in your model. In our case here, let's select the bolts and the nuts. And from here, let's select the stud bolt. Let's open this one. Okay, and let's define the dimensions of this tie rod. Okay, to get this form, which is iLogic form, if you don't have it, if it's like that, it's not included. From View tab, okay, so kindly store those steps to know how to open the iLogic browser. So from View tab, open the user browser, and you will find a list of browsers here. Select the iLogic browser. Okay, so it will appear here in your model. So it's a floating toolbar. You can move it and add it anywhere you would like to use. After that, you will find many tabs here. One of them is the Forms tab. Select the Forms tab and click on the stud bolt form. From here, you can select the type to define the stud bolt dimensions, if it's an ISO or ULC. Okay, so let's select ISO format, and from here let's define the diameter of the bolt. So before that, let's check the hole diameter size. I think it was 32. Okay, so it was 32. So let's select a standard stud bolt with 30 millimeters diameter, and from here let's measure the required knot spacing, which is the spacing between knots. Here it's 88.5 millimeters. That's the spacing between knots. Okay, so from here let's define the length of the stud bolt, find the spacing, and from here let's select the size, which is 30 millimeters. Define the material of this stud bolt, define the part number based on the bill of material, and we will discuss that after creating the stud bolt and adding it to the assembly, how to include this item in SEG bill of material. Okay, but right now, let's keep this item as it is. Kindly take care from the next steps. Okay, give me your attention, please. Here, if you would like to save this item here from Autodesk Inventor, if you click on Save, you will not get any response because SEG now takes the control. So if you would like to make save or modifying for a new item, just come back to SEG again, and from the Assembly tab, you will use those buttons. Here, we need to save this document. It's a new document. Okay, it's not saved yet. So from here, click on Save Active Document here. And if you come back to Autodesk Inventor, you will get this form. Okay, so let's create a new folder for new items. Items by SEG Helper, for example. Okay, and now let's add this item as a stud bolt in 30. Okay, and let's save this item. Okay, now let's create a nut. By the same way, let's open new, and from here, let's select SEG item template, select bolts and nuts. From here, let's select a nut. From this four, let's select ISO nut and select the size of this nut. Define the material of this nut and the part number, which will appear on the drawing and bill of material, but keep it like that right now, and after that we will modify it after importing it to SEG. Okay, by the same way, if you try to click on save, you will not get any response, so you should save from SEG. So click on save. After that, come back to Autodesk Inventor and save this item as nut M30. Okay, now we have two items, stud and nut. Let's create a new assembly, include those parts. So from here, let's add the stud bolt here. After that, let's add two nuts. Okay, to assemble those nuts, we need to assemble by using the constraints. We have here a constraint for nut 1 UCS. So let's open the constraints from here, or by clicking on C button from the keyboard. So it's the shortcut order, which is C. So you will get this form, and select constraint set, okay, the last one here. So from here, select the nut 1 and start UCS for the nut 1, and for nut 2 with start UCS for nut 2. You can figure that if we measure the spacing between nuts, which is the length from the inner faces, it's 88.5. It is not enough. So you can come back to the stud bolt and change the length of this stud bolt. So let's 160, and come back to the assembly again. And now you have an updated assembly for the nut. Now let's save this assembly to use it. So as mentioned, you cannot save it from here. You need to come back to SEG and save it from here. And it's stud bolt the assembly. Okay, now we can use this one in our assembly. So from here, let's import this one. So place a component. Let's add this stud bolt. And from here, by using the constraints, let's add this one. And let's make a pattern, circular pattern. For this one, we have 20 bolts, and they are 360 degrees. Okay, so we select this one. So let's select the component again. Sorry, that's the component again. Select the pattern component and the side diameter. We have 20, and that's 360 degrees. Yes, divided by 20 bolts. Sorry. So now we have those bolts like that. Let's add the same bolts here. So from place component, let's add this stud bolt here, and let's assemble it from here to there. So let's select this one, and another stud bolt down here. That one there. Now let's make a pattern for those. So select those. Circular pattern around the center of this flange. We have 360 bolts. But now we have those bolts on the flanges like that. Okay, now let's add another stud bolts for those. By the same way, you can open the new item, and from SEG, you can select a new stud bolt, define the new size for this stud bolt, save it, and make a new assembly and make one like this. Now let's proceed with the tie rod. So from view, let's take a half section here. We need to add two different tie rod lengths here to this one and assemble it. And if we would like to make a tie rod connected to the second tube sheet instead of the first tube sheet, how we can deal with this? Right now, let's create or generate a new tie rod. So from here, from the SEG template, let's select tie rod and the ceiling rod, and from here, let's select the tie rod, and let's make the length 1 meter right now. After that, we can modify it. The diameter is let's make it 14 millimeters. Penetration, thread size 12. Okay, we get this message because the diameter of the thread is larger than the diameter. So when we adjust this, we get the correct configuration and the thread length here and there. Okay, now we have this tie rod. Before this point, I forget to inform you how to include this stud bolt and the nut to SEG library. Here, if we go back to SEG tables and from bill of material, you will find an option here to add extra bill of material. Okay, now you have the last element is 31. That's the last number in your bill of material. So when you open an extra bill of material, automatically the item number will be defined, will be sorted automatically as a new version, which is V4.05. We make this modification, so the sorting will be automatically sorting. Now we have to calculate the number of those bolts. We have 3 seats here. We have 1 seat, another seat, another seat. In each seat, we have 20 bolts. So totally, we have 60 bolt. Technical characteristics, it's M30 is length equals 160 millimeters. The material is a 1.4 H2.4. Let's check the material that we used it here. So sorry. So the material for this item is, say, like that. So let's take this one as it is and define it here. And the weight of this item, if you would like to calculate the weight, so from here, let's get the physical properties of this item. So the weight of this item will be like that. If we do it like this, and so the total weight will be like that. So we can add it to SEG bill of material. Part name is bolt M30 and that's the part number. So we can name it 32. Remarks, no remarks. Now, if you click on save, it will be appear on the bill of material. Now let's add the nut. Okay, so you can figure that this element now appears here in your SEG bill of material. If you would like to add another element, which is the nut, you should select the equipment here from this one and define the.
Sir, I have a question.
Yes.
Sir, how can we change the item number that generated by the SEG software?
No, it's not possible to change it. It's generated automatically from SEG. If you would like to change it, you can do that. Not from
And how?
SEG, but
Okay, sir.
yes.
And how can make sub-assembly in BOM of different parts?
Yes, we did that right now for the stud bolt. We make an external assembly, external parts, and add them to our model. Is that your question, or something else? You are asking for something else?
So actually, we are having some standard part numbers. Generally, we use only the same. But can we customize these part numbers in SEG? Actually,
Like we're using the tube sheet number 3 and 4.
Mm-hmm.
Can we customize it in SEG software?
Right now, it's not available from SEG, but you can customize that after exporting your drawing. You can make this modification on the bill of material itself.
okay.
You will get a table in your drawing. This table is
okay. And sir, another question. In tie rods, we are also using spacers.
yes, I know.
Yes,
all the fabricators using the spacers.
Yes,
but it's not included in SEG. In SEG library, but it's included in SEG helper, like the bolts, stud bolts, all of that.
Sometimes
shackles, we have shackles, many things in SEG helper. You can use it to generate.
Sometimes face problem to count the numbers during bundle preparation. This SEG software help us to count the quantity of spacers?
Autodesk Inventor can help you with that. I will show you that. I will show you.
Okay.
After making the tie rod, inshallah, the next step after adding this nut on SEG bill of material, we will proceed with the tie rods. We have two different lenses for tie rod. After adding them, we will add the spacers, and we will make Autodesk Inventor calculate the required number of spacers and get a bill of material for the spacers, a separate bill of material for the spacers with the lenses. Is that okay? Now, the description of this one is not the material of this element. That's not, and here that's the material. Okay, and the weight of this not the weight of this one. Okay, so let's get this value. So we have weight. 30. Okay, the part number will be 33, and click on save. Now you can figure that you have those items included in this external bill of material, so you can modify or edit on them. Okay, now to reflect those numbers, here we have 32 for the stud bolt and 33 for the nut. You can reflect those numbers here. We have that one is 32. Okay, that's the part number which will appear, and that's the item number or part number for the nut. Now let's save it, close, save that one and close. Okay, let's save the stud bolt assembly, and now let's proceed with the tie rod assembly. Here that's the bill of material. After creating it, let's close. Now let's generate a nut for this tie rod. From here, by the same way, let's select a nut, and from here let's select the nut size, which is 12. And let's make it, it will be 34, let's have 35, item 35 as a nut. Okay, now let's save the tie rod first. So from Assembly tab, let's click on Save Document, and from here it's tie rod 1, because we have two tie rods, two different lenses. So that's the first tie rod, and that's the stud, the nut. By the same way, let's save it. So it's tie rod nut, and let's create a new assembly to include those items. So from here, let's place the component for the first tie rod, and here we have the second nut. Let's add two nuts here. Okay, we have let's add this nut at the end of that one. Sorry, let's add it here to be located after that one, and make those sectors are flushed. Now let's define the location of this nut from that one, so we can measure the distance from here, sorry, to that surface. Let's define it as that. So now we have this tie rod. Let's save it. So let's save this tie rod. So it's tie rod 1 assembly. After creating this tie rod, we need to import it to our drawing or the 3D model. So from here, let's make these tubes visible, okay, to give us enough space to figure out the inside here, to be able to add the information of the location of the tie rods. Here, if we open this tube sheet, you can figure that you have here the tie rod locations. Okay, so those are the locations of the tie rod. If you would like to make a modification on the tie rod by double clicking on this one, you can define the hole of this one. The thread is 12 millimeters, and if you would like to change the projection, or let's take a look from the left hand side, so you can control the projection of this one. So if you would like to modify the projection like that, or control the angle of the end of the tie rod, you can control it from this form. By the way, the scale here, the location of the tie rods here is it's appear here. Let's take a look from this view. Here you have those nodes, or the location of the holes. You can change it if you would like to change it, add or edit or delete some of them anytime. So you have this whole locations. Now we have the tie rod locations here. So let's take a half section, but sorry, keep it as it is, but let's make this shell invisible and make everything clear. Now we have the view appear like that, and we would like to add the first tie rod. Okay, so from assembly, let's add the first tie rod assembly. Okay, that's the first one. And from here, let's select this constraint, select this one, and select this hole, and make the penetration of this one inside the tube sheet. So let's define this penetration with, let's say, 30 millimeters. So it will be located inside this tube sheet with 30 millimeters like that, and that's the hole inside the baffles. And let's click on OK. Now for this one, we need to modify the length of this tie rod to suit the last baffle. So if we make a measure for the last baffle to the end of the knot here. We need to this knot located on that one. So we need to increase the length of the tie rod with that value. Okay, 1,314. So let's come back to the tie rod again. Sorry, to tie rod because we generated manually. So from here, let's open that one. And the length here, let's add this value, which is 1,300, and click yes. So now we have the updated length for this one. We come back to the assembly and click on update. We will get the updated one. Again, let's come back to the 3D model and click on update. Now we get the tie rod with the correct location. By the same way, you can add the other tie rods, but here we have that one will be with a shorter, no, not that one, the below one here. Okay, that one. Okay, that one will be with a shorter length, not the complete length. So let's add the other tie rods for that one. So from here, let's add the other tie rods. That's the first one. So let's add it here. That's the first hole. Okay, another one there and another one there. So let's add 2 tie rods. Okay, another one. Now let's generate another tie rod with a different length to suit the location of this baffle. Okay. Okay, so those. Oh, by the way, this one is not a correct one. We need to move it down here. So let's modify a constraint for this one. So let's edit the constraint. So let's move it here. So we need to select. Sorry, we need to select edit. Let's select this one. So we moved this tie rod. Sorry. So this rod also not include. So we have 3 short rods. We have 3 short rods. So we will delete that one from here. So we have 3 long rods and 3 short rods. So to save another tie rod from that one, we already create a one, and we need to make a copy from this one. You can make it by 2 ways. The first way is the easiest way, which is take a copy from that one and rename it with tie rod 2, like that. Okay, after that you can open it and modify the length. Or from here, if you have this tie rod, you can make save as. Okay. So from save as, you will make a new copy here. So you can name it as a new part for as a new tie rod as a new part. Okay, so tie rod 2. Okay. So by saving it as a tie rod 2, here if we open that one, you will find that one here, which is tie rod 2. I add a dot. Sorry. So let's open it and modify the length. So the length required here in this case which is 150 millimeters. So we need to decrease this value from the tie rod length. So here, if you open this 4 and decrease that one little bit, you can decrease 150 from the length of this tie rod and click on save. The same thing we will do it with the assembly. We will take a copy from that one and make tie rod 2 assembly. Here. If you open it, you can replace the tie rod. So we will replace the tie rod with the tie rod 2. Okay, so here we have the new assembly of the tie rod 2. Let's close those assemblies here. Okay. Now we have that one. Let's import the tie rod assembly tool. Here we have this assembly. We have 3 rods. Okay, now let's add them by the same way. Here, let's add this rod here. Okay, the second one. I'm showing you how to make that. If you haven't the ability to make it with SEG, you can make that but a single rod with a single lens, not 2 different lenses. So you can make 3 of them by SEG, but the other 3 tie rods, you can do them as we did right now. Now we have those 3 short tie rods here. Okay, so we have 3 long tie rods and 3 short tie rods. By the way, I forget, sorry, it's not the last baffle. Okay, so we can make a modification for that. So let's make those items hidden. And let's make a modification for the length of the tie rod, because that's the last baffle, not that one. To modify that, it's easy. So we need to measure the distance required. Here we need to increase that one by 1 meter and 20 millimeters. So let's open the assembly of this one. Double click here for like that. Sorry. We increased the value of the tie rod. Where is the issue? Okay, so let's close this one. Let's open the tie rod itself. So from here, let's open the tie rod one. And let's modify the value. Value of the parameter name is going to be send to Kaza. I think we need to close Autodesk Inventor because we receive this message from Autodesk Inventor itself, not from SEG. So we need to close this one. So let's close this project. Okay, and let's close SEG and close Autodesk Inventor. Now, if we have another instance from Autodesk Inventor, we need to close it by Alt Control Delete to get the task manager, and check if you have another instance from Autodesk Inventor appear here. You can close it to avoid any other issues. So here, no other instances from Autodesk Inventor. One more here, Autodesk. That's one of the issues you may face it during working. So you can deal with that easily. Just close the application if you face something like that, and reopen it again. Okay, now let's open SEG again. And let's open the project. So it's the demo of today. Okay, and let's open the assembly. Okay, the changes that we did by adding the tie rod, we didn't save it. Okay, now let's add the tie rods again. So from here, let's take make those main elements invisible. Okay, so let's make them invisible. And for the tubes, let's make it invisible too, so to make the view clear to us. Now let's add the first tie rod. So from here, that's the helper, that's the first tie rod. So let's add it from here to there, and let's make it that value, and let's modify the hauling as we modify here. Let's make the thread, make it 5. Okay, for this rod, we need to make it up to that one here. So we need to measure the required length from here to the end of the knot to there. So that's the value, 2514. So let's open the first tie rod. But let's measure the distance again. I forget the value from here to there. Okay, so let's take that one, copy, and from the form here, let's find the required length. Okay, now we have the updated length for the tie rod. Okay, for the short one, let's add the long one, which will be tie rod 2. Here, let's add it as a bottom here. Okay, so the required length will be the same plus 150. So let's open tie rod 2, and it will be like that. And let's close this, and let's update. Now we have this tie rod. Now for the spacers, by the same way, we will complete the other tie rods. Now we need to add spacers to this tie rod. But a little bit to get a tie rod from the tube sheet to here. So for baffle number 1, we can increase this cut a little bit like that. And for the second baffle, we can increase this cut. And let's run this simply. Okay, now the baffles cut is updated. Okay, and by that way, we have the ability to add spacers to the model. We need a spacers with that length. So from here, let's measure the value from here to there. Okay, we 446 millimeters. So from new, let's open SEG, and from accessories, you will find the spacer tube. So let's open the spacer. And from here, let's define the diameter of the spacer, the thickness of the spacer, and the length of this one, the number as per SEG bill of material. And now we can save it. As mentioned, if you try to save it from here, you will not be able. Just go to SEG and save it from save document. And 1, or let's define it by length. Like that. Now you can add this spacer here. So from the assembly, let's add this spacer, and let's add a constraint to this one. You can add it directly like that. So you have a spacer on this tie rod, another spacer here. So let's measure the distance from here to there. It's 296. So let's create another one. So that's a spacer with the lens again, lens 296. So from here, the spacer length will be like that. The spacer, modify the length. And let's add it to the assembly. Here we have this spacer at that area. So we can, let's add the spacers on those slides to show you how you can calculate the required number of these spacers after adding it to the bill of material. That's the second spacer. Third one. Okay, we have that one. The long spacer. Another spacer here. So now we have those spacers on the model right now. Okay, and by the same way, you will add the spacers from here, but you can make a pattern. You can make a pattern after that for because the spaces here are identical up to there. So let's add a one and make a pattern for it. The spacing here is 300 negative the thickness, which is yes, it's 282, 92. So let's take a copy from this and define the name of this one like that. Open it. Okay. Let's save this one. Close, close, close. Now let's import those spacers here for tie rod with that lens. We have these spacers here. So one here to there, third one from here to there. Okay, another 3 at the top with the same length because the spacing is the same, So let's select. Okay, one, another one here. Okay, now you can make a pattern for those typical spacers. we have three typical spacers here. That one. So we can make a pattern along the axis of the one, along x, y. So from here, let's select x, y. Okay, so let's select x, y from here, and we have 1, 2, 3. So 11 identical spaces with 300 millimeters space. And let's click on OK. So if we are selecting the correct one. Sorry, so we need to flip the direction. Here, that's the pattern. Flip the direction to the other side. So we have spacers on that direction for that one by that way, like that. And for the top spacers, let's select the top spacers and make a pattern, rectangular pattern along the y direction, like that. And spacing is 300 flip the direction. Now if we take a look here, we have spacers on the direction like that. Okay, now we have the total spacers inside the model. In the bill of material, if we open a drawing to check the bill of material of that one, let's add this model, quick model here, and from the pattern, let's add part list material, bill of material, and let's open those spacers. And okay, let's make that value indicate the part name. So here, let's add the part name, file name. Okay, let's add the file name. Let's remove the description and part number, and item from here. And okay, so the file name and the quantity, I think it's okay. So here, let's modify the width of this one. Here for the spacers, here we have 3 spacers with that length. We have another 3 spacers with that length. We have 63 spacers with that length. So you can get the number of spacers from Autodesk Inventor bill of material by that way. Okay, let's close this one and make everything here again for the tubes and panel. Okay, by adding those items to SEG bill of material, as mentioned here for the external bill of material, you can add new items like the tie rod nut and the spacer as we did. Now let's add tailing lug and lifting lug to this heat exchanger. Okay, let's add a tailing lug and a trunnion here. So let's select can 2, which is this one, this can. Let's add a tailing lug on this one. So from here, let's select elements, and from lifting group, you can find some types of liftings, and from here you can select lifting lug 1, and let's make lug. And for this tailing lug, you will find a type for as a lifting lug option. So from here you can define the tailing lug dimensions, and if you would like to add a gear plate, define the sequence of the gear plates, the material, the location of this one, the orientation. Let's make it on 0 degree if you would like to add a cooler for the lifting lug. After that, you can generate the 3D model for the tailing lug. So here we have a tailing lug like this. So if you would like to modify the location of this one a little bit, so we can decrease the location to make enough space between this body flange and this lifting lug, and we can add a trunnion. So from here, let's select can 1. So we will add the trunnion on this shelled course. So let's select can 1 from here, and from there, let's select trunnion. From this trunnion, you will find 2 different types. The first type, trunnion from blade, and the trunnion from pipe. In this case, let's select a trunnion from pipe and make the size of the pipe as 4 inches with the scalable 160. The projection, let's make it. The location, let's make it. The orientation, okay, because the tailing lug at 0, so we will make the orientation at 90 and 180. We will not add end blade. We will add 2. Yes, let's add an end blade. So, and for the rebad, let's make That. Let's add a single ring, not two rings. So many options here for the tailing lug, and on our tutorial videos you will find a discussion around the available options for the trunnion. The outer ring will be 150. So let's add the offset outside, and we have two trunnions here. And let's click on save. Now let's create the 3D model of the trunnion. Okay, now we have this trunnion like that in that location. We have an external end blade, and we could change the location a little bit to avoid. If you would like to measure the distance here by using the inspect tool, and from measure, you would like to measure the minimum distance between those parts. So from here you can select part priority. So you will select this part and the second part. Here you will get the minimum distance between those two parts. So after adding the fillet welds, this space will not be enough, and may the client not accept this clearance between welds. So in that case, we could increase the location of this trunnion. So, from here we can change the location, increase it like that, and click on save. Now if we click on start assembly, we will change the location of the lifting trunnion. Now let's measure the distance. Select parts priority, not surfaces or edges, and measure the distance. I think now after adding the fillet welds, this area will be enough. Okay, now let's add the stud bolts that we when we added at the first time we didn't save before closing Autodesk Inventor. So let's add it here, there, another one there. So here, let's add that one, another one here. And now for those, let's make a pattern. Let's select those, and from here let's select pattern number is 20. Okay. Select it and make a circular pattern. Select the center line. Define the the total angle and number. So we have this one right there, and if you would like to measure the or calculate the total weight right now for this. Okay, any questions? Yes. Okay, here for some types of flanges, like this type of flange, there are some available options to or attachments you can add it to those standard flanges, like stud bolt or lifting lug, different types. But for those type of flanges, which we used for the heat exchanger, which is loose slip on flange, we haven't a stud bolt attachment here. So we go to the direction of making this stud bolt by using SEG helper. Okay, so for some types like that type, you will get a stud bolt, so you can create it directly from SEG library. No need to to create it by the helper, and automatically it will be included in SEG library. Any questions before going to the next part, which is generating the drawing? Because I think we have 45 minutes or 30 minutes to end this session, because I should to go Gom'a break, inshallah. Okay, any questions?
Hello.
Yes.
Sir, I have a question in regarding BOM.
Mic one.
Bill of material, sir.
Yes. Okay.
Sir, first of all, there is no automatic update is provided in BOM if I change any model or drawings in the SEG. How can we update the BOM, sir?
Okay. Who said that no update? It's updated, but you should select an option to update the bill of material. I will show you how to can do that. Kindly, I shared a lot of training videos. I think image graphics team share it with you. In those tutorial videos, we make many different samples, real samples for a real project, and all of those points we covered it. I will show you how you can do that, but it's better to watch those tutorial videos, which will discuss a lot of options, a lot of cases, because here we discuss a certain case for a heat exchanger, but there are different cases, different configurations for the pressures vessels. It's the same. So during the training videos, you will find a lot of your questions already answered. Okay, here regarding your point for the bill of material, that's the generated bill of material here. But in the drawing, if you, for example, let's create a quick drawing to show you those changes. Here, let's select elevation view, and from here, let's select the right view to be the elevation view for our case. That will be the elevation view. Or if you would like to make the left view, take a look to that one. So that will be the left view, will be the elevation view on the drawing. Okay, so here let's of this one and make the scale 240. And the tables, let's add the bill of material table, design data table. Okay, and I think it's enough here. Let's keep everything as it is. But right now, let's create the drawing. I need to change the size of the drawing here. That's the bill of material. Okay, by the way, I will repeat this drawing by adding a nozzle table, and we will modify the nozzle table and the bill of material table, and I will show you how to reflect the updating in the drawing again. Okay, here that's the building details. Okay, here let's delete this drawing and recreate it again by changing the size and adding, let's change the size. Okay, let's add another view. Let's change. Okay, let's keep that one as it is. Okay, let's remove the welding styles and the notes, and let's add the nozzle table. So we have a bill of material and a nozzle table, and let's add the design table, and we will make a change on all of those values. Before going to the next step here, that's the option which will give you the ability to update the tables, which is update tables automatically. We will not select it right now, but let's create the drawing. Okay, now we generate the bill of material, and you can figure that the numbers start from 1 up to 33, 37, 33. We need to update the bill of material. So from bill of material here, we need to update the external bill of material. So it need to be updated. Okay, so let's close this and let's add a new item to here and add another nozzle. So if we add another nozzle, we will get a new items for inside the bill of material. So let's select the CAN one, and from here let's add a forged hub with a flange. So from here let's add S3, and this forged hub nozzle will be a self-reinforcement forged hub. So let's select this self-reinforcement forged hub and let's make it with 4 inches size with schedule 160, and that's the height of the hub, the hub thickness, and here's the bevel height. So if we to get 45 degrees for the hub, so if we increase the thickness from the hub thickness, sorry, so that's the bevel height. So we will get this bevel height here, and that's the width of the hub, the thickness of the hub. So let's make it double the thickness of the shell, and from here we will make a chamfer on the end of this one, 3. Okay, and the location, let's keep this location and let's keep the orientation, no problem. And from here let's add a flange, S3. Okay, so this flange, let's select rating, size, and schedule, and let's click save. Now if you open the bill of material, you will get the forged hub in this bill of material. Here we have this flange, the new flange here, which is 4 inches size, and for the hub thickness, you have a self-reinforcement forged hub. Now they are new items on the bill of material, and we need to reflect that to the bill of material. By the way, here we have a new items on the nozzle table. Here we have S2. It's a new item on the nozzle table. So how to reflect those tables to our drawing? By the way, let's make a change on the design data table. Let's remove some of those rows. We don't need them, or by modifying something like that, and click on save. Now the design data of this equipment is modified. Okay, so those values will not be needed. Now when you generate the drawing again, and from the tables, you should select the required tables that you would like to update. Here in our case, we need to make update for the bill of material, the design data, and the nozzle table. So to update them, you will need to select update table automatically. So this option will give you the ability to update the selected tables. The same thing for the welding details. If you increase the welding details, remove some of them, and you would like to make an update for the welding details, you will need to select this button to give you the ability to delete the non-required welding details and add the new required welding details. Here, after clicking on that, I will make a small modification here, increase the spacing between two views, and change the location of the main view, and recreate the drawing again. Modified, now it's modified, and refilled again with the new values. Okay, the design data. Why the location of the tables not takes the original location? Because we miss to select an option, an important option here, which is the, after creating the drawing, you should select from the design style, you should select the required number of sheets per drawing and save the information from here. That option will give you the ability to save the location of tables. So when SEG try to edit the table, it will keep the location of the table as it is. Okay, so here let's save this option. But right now here you have the nozzle table location. Let's check it after moving it back. Here you have S2, that's the new one. Okay, and sorry, it's S3. That's the new one that we had. It's an inlet nozzle, 4 inches. Okay, and that's the information of this nozzle. The same for the design data. If we take the design data and move the design data from here out to there, let's move it here. So the last one was the year of construction. So the capacity, fireproofing, insulation, or non-selected files, now it's deleted from the bill of material. The design data. The same for the bill of material here. Okay, so the N4 flange, 4 inches flange, now it's appear here, and the self-reinforcement forged hub appears here. Now, if you would like to make a modification for the tube sheet, for example, as you mentioned, it takes a defined number in your workshop, for example. Here, so let's select the tube sheet. So the item number, you can modify it like that. So you can modify on that table and the reflection will appear directly on that table. But take in your consideration that any change, any update from SEG will clear the information updated on that table, because SEG will send the new information which is not include those values. Okay. Any questions regarding bill of material update or the civil model?
Sir.
Yes.
Sir, I have another question regarding BOM. Sir, if I hide some parts in BOM, then how can we maintain the other part quantity and their weight in BOM?
Like what? Give me an example.
Sir, like in this BOM, if we hide some atoms, okay, sir. And after that, we will show, how can we will show the other parts weights and item numbers, quantity of items, sir?
On the bill of material. So, okay. That's okay. Here, that's the table generated here. If you, for example, if you would like to make the shell courses not appear, just select them from here and make them invisible. Okay, so they will be keep on the bill of material, but when you it will not, just you make them invisible, but they still included here. Okay, and if you would like to make a bill of material for let's say for the clips itself, you can make that by selecting the item for the support lug, for example. If you prepare a drawing for this one and make it a drawing from S3, and let's open this slug in separate model. So let's open it like that to know which view we will select. So if you select that will be the elevation view. So let's select this one and make it top view and define the location. Location. Now you can add a bill of material for this item here. If you select the bill of material and define that one, select save. If you generate a drawing for a group or sub assembly like that, you can make a separate bill of material for this item. So here SEG create a separate bill of material for this support, which is item 29, 30, and 31. And those are the items: base plate, rib plate, and wear plate. Here's the quantity and the weight of this support. By that way, you can make a separate detail for the items. And there are some other videos regarding the group options and how you can make a group by making the channel assembly, shield side assembly, tube bundle assembly, how you can make sub assemblies inside your model. If you give you the ability to make a separate drawings for this. Here a video. In this video, we discuss the options of the group and how you can make a group, delete a group, modify inside the group. Here another tutorial or training video for a heat exchanger from A to Z. Another tutorial for heat exchanger AES type with a clamp on the shell side. Many other training videos. I think Image Graphics team share those videos with you to give you a lot of information about how to use SEG and how to use the different options for the items. Okay. Any questions regarding the bill of material or the assembly?
Hello, sir.
Yes.
Sir, I have a question, sir. How can we reflect the unhide items in BOM, sir? Reflect the item quantity and weight in BOM, sir. Unhide.
Okay, here we make a hide for some items, so you can select them and make them visible again. Is that your question or
no, sir?
Or not?
If we hide some items in the BOM, and then after that, how can we maintain the unhide items quantity and weight in the BOM? Total quantity, sir. Total quantity and total weight.
The number here you are talking about.
Yes, sir.
Yes, as mentioned, if you would like to make a separate
unhide, sir. Unhide item.
Yes. Listen to me, please. One minute. If you would like to make something like that, you can do it, and automatically SEG will calculate that. But if you make it manually, you should complete it manually. If you unhide those items, so you should calculate the quantity of those items and decrease it from the last value. And the same for the weights. You should calculate the weights here because you do that manually. So you should complete it manually. Okay. I will show you how you can do that. Okay. Let's take a copy from this one and open an Excel sheet. Let's come back to the desktop here, and here on this folder, let's create a new Excel sheet. Okay, let's open this one. Okay, and list it based those values here. So we have those. So let's select those and arrange those like that. Now we have. We will make those. Yes, we will make those items unhided. Okay, in a bill of material. So that. So we can sum them here. So the summation of those. That's the summation of those, and here the summation of those. So let's write it here. So those. So we have those. We have 8 items. We need to decrease them from here, and another weight we should decrease it from there. So we can come here and write equal negative that value. And for that one, we can make equal negative the removed items. So here you have the new weight and the new number of items. So you can take a copy from that one and come back to bill of material. After removing those, you can modify this value. Okay, the same for the quantity. You can come back and modify that value by that way. Now you have the modified value and modified number after hiding the items from the group. That's the way if you will start to making it by hand, because now no control from SEG. It's you want to make some custom modifications, so you should take care about what you do. Did I answer your question in a correct way, or still you have an issue?
Okay, sir, I understand. Sir,
okay.
Another question is, sir, design data regarding how can we import the design data from Excel sheet with merge cell, sir?
Okay, no problem. Already we discussed that in another videos, but let's try to make it here. Okay, let's create a new Excel sheet. We have here a new Excel sheet. Let's name it as like that. And from here, we will open a new Excel sheet. And if you open the heat exchanger module, you can figure that you have 4 columns. You should fill the 4 columns, no empty rows, and automatically you can start with the values like the construction code. For example, let's start. Okay. And the second value will be as me. For example, like that, and the last cell, let's add 1. We have 4 columns, so let's fill all values. The this one and shell size. Sorry, that's shell side. Another value, another empty value. Here we have design. And yeah, and regarding to write a degree, you can add it like in AutoCAD. If you would like to make a degree, you will need to write it in that format. Okay, so like that, and you can complete that. After saving that one, you can import from Excel and select the Excel sheet location, which is located on desktop. No, it's not here. So it's a new folder. Sorry. Okay, I think we need to make a modification on the external library for the office, because we just in the new version, which is v4.05, we add a new external library for Microsoft to give the user the ability to import and export without needing the office on his machine. But I think we have an error in this, so I will check that with the team, because this feature we just included in the new on the new release, but it's working correctly on the previous releases, because on the previous releases we didn't include the this library. So I will need to check it with the SEG development team. Okay, but that way, by the same way here, after including the Excel sheet, you can include it easily to SEG software. Okay, and inshallah we will give you a feedback about the updating of this issue. If you still have version v4.04, you will not face this issue to import from the Excel sheet. What if you would like to modify that here as discussed automatically? You will double click on the cell and modify the value that you would like to include. Like that, if you would like to make this value visible or invisible, you can easily modify that and save the values. Any other questions?
Sir, how can we use the earthing lug on saddle and lug sport, sir?
Again, what is the hexagonal saddle? What is it?
Sir, how can we use earthing lug on the saddle?
Earthing lug, yes, earthing lug. Sorry, I'm hearing
grounding lug, sir.
Okay. We have a case here how to add a grounding lug to an item. Let's say a saddle. Let's add a saddle to this model and check. By the way, all of those points we already covered them on the training videos, but let's say it again, no problem. Okay, here let's add a saddle. Let's add one of those cradles, a simple cradle. Here we have this type of cradle. Let's keep the dimensions and as they are. Make a slot 1. Let's create this support. That's the forged hub I created here. We didn't create it, and that's the saddle. Okay, so let's add the an earthing lug to this one. Okay, as mentioned, for the childs, you will not be able to add another attachment. Here we have a saddle, but no attachments here. So let's add an earthing lug to the main element, which is the shell. So after selecting the shell, and from here select grounding lug and add a grounding lug from the external attachments. Here you have an attachment, select the suitable type, define the dimensions and click on save. Now after creating this element, it will be generated on the shell, but we need it on the saddle. So how we can move it from the shell to the saddle? Okay, here it's easy to assemble this item with the shell. So we will delete those constraints, and now the grounding lug is free to move. So you can make a new constraint to this one, like that. Make that surface parallel to that one, and make that one offset from the base with, let's say, 20 millimeters, 100 millimeters. So that way you can do that, and the tailing lug will appear on the SEG bill of material because it's included on the library. Any other questions? I hope that you get a chance to watch the training videos. A lot of those questions already covered. Any questions?
Hello?
Yes?
Sir, how can we use the nozzle on cone elements?
Yes, okay, we have a cone here.
And
we have a cone.
Saddle wrapper plate also, sir.
And what?
Saddle on cone.
Saddle.
Okay. Now we have a cone here. So if you select the cone, you will find the available attachments for this cone. One of them is a saddle, nozzle with external connection, nozzle with internal and external connection, external stiffening ring, insulation, and clad. Now let's add a saddle to this cone. Okay, so let's open this saddle. And here you will get the different configurations for this saddle on the cone. And if you would like to add outside ribs or make the web with that shape, so you can define the dimensions of this saddle for that. Let's define the height. My base plate. Let's let's add outside ribs. Decrease the bottom plate width. So let's add mid rib. Okay, and let's click save. Okay, so but by that way you can add saddle to a centric cone. But I think the dimensions is not, I think it's greater than the, because here the width of the wear plate is greater than the cone dimension. So if we can add a new cone and define the saddle dimension, because we may get an error because the dimensions of this saddle is greater than the cone dimensions. Okay, yeah, the same for the location. So the location and the wear plate width, here we have the saddle, so we need to modify that little bit. So here, let's make it like that. And the location, I think the length of the cone, at the half of the length of the cone, the height, keep the height, base plate length, base plate width, no problem with that. But the top width, okay. And one more thing here, we need the bottom width. Okay. Delete the previous elements if they are include any issues. Okay, as you can figure, the assembly created on behind. So if you would like to make a rendering for elements during creation, I will show you an option. Here you have a saddle on the cone. By the way, you can make this saddle on the centric or eccentric cone. Okay, you have this saddle here on the cone like that.